Welcome back to the chemical bonding chapter. So in the previous video we have seen some bond characteristics, properties of some covalent and ionic compounds. Now let us go for the formal charge on atoms in a molecule or ion. So it may be ion or a molecule. Individual atoms may not be having any charge, but still it is necessary to assign the charges on the atoms so that it will be helpful in determining so many other properties like dipole moment, etc. Suppose you consider the formal charge. So it is defined by this equation, formal charge, or it can be calculated. Formal charge on an atom in a molecule or ion is calculated by using this equation, is equal to total number of valence electrons on atom, for which we are actually calculating the formal charge. We have to consider the valence electrons of that atom minus number of lone pair of electrons minus half into number of shared electrons, which are nothing but bonded electrons. These are bonded electrons, these are non-bonded electrons. On an atom, if there is a lone pair, it should be taken as the lone pair of electrons. We should subtract it from the valence electrons. Let us take, for example, ozone molecule. Ozone. This ozone is actually represented by the structure that is called Lewis structure, like this. Even though it looks like all the three atoms are identical, there is a difference among the atoms. These two are bounded by a double bond and these two are bounded by a single bond. And let me assign this number as 1 and this as 2 and this as 3. Now from the Lewis structure, each oxygen atom will have certain number of lone pairs to complete this octet. Since 4 electrons are present as the bonded electron, 4 electrons are present as the 2 lone pairs. Here 6 electrons are bonded, that's why 1 pair of electron will be present as a lone pair. Since only 1 pair of electron, that is 2 electrons are between the 2 oxygen atoms, 6 electrons are present in the form of 3 lone pairs. So whatever the dotted pair that I have written, it is nothing but lone pair. This structure is called as the Lewis structure. First write the Lewis structure for the molecule, then write the number of lone pairs as per the requirement so that octet is complete, and then you assign some numbers to these atoms and calculate the formal charge for all these atoms. So let me calculate formal charge on oxygen 1. So this is written as equal to number of valence electrons on the atom. For oxygen atom, totally there are 8 electrons, but 2 electrons are present in the inner orbit and 6 electrons are present in the outer orbit. That's why we write this as 6. Better you remember 1s2, 2s2, 2p4. That is the electronic configuration for the oxygen atom. 2s2, 2p4 will indicate the valence electrons. That's why we have to write number of valence electrons 6 minus, for this oxygen atom the number of lone pairs are 4, minus 4, minus half into the number of shared electrons, that is bonded electrons. Bonded electrons are actually 4 in number. One bond indicates 2 electrons. That's why two bonds, multiple bonds indicate 4 electrons. That is minus 4. That's why it is equal to 6 minus 4 minus 2, that is equal to 0. So this oxygen atom indicated as number 1 does not carry any charge. Now let us write the formal charge on oxygen 2, that is central oxygen atom. Now we can write this formal charge is equal to the number of valence electrons 6 minus the number of lone pairs only 2 minus half into the number of bonded electrons are 3. Bonds are 3, therefore 6 electrons. So it is equal to 6 minus 2 minus 3, that is equal to plus 1. This oxygen atom will carry positive charge. Formal charge on oxygen 3, third oxygen. I told you all oxygen atoms are same, but they are present in the different chemical environments. So this third oxygen atom also has the valence electron 6 minus the number of lone pairs are 6, lone pair of electrons are 6 minus half into, there is only one bond pair, that's why it is into 2. For each pair, each bond we write 2 electrons. So it is nothing but equal to 6 minus 1, that is equal to minus 1. That's why we can rewrite the structural formula for this one as O, double bond O, single bond O with lone pair of electrons, one pair of electron here, 3 pairs of electrons. So this carries minus 1 charge, this carries plus 1 charge, minus 1 plus 1. Now let me take one more example. The second example is carbonate ion. Carbonate ion. Carbonate ion is actually CO3 2 minus. First you write the Lewis structure, C double bond O, O minus, O minus. Just a single bond O. Write the number of lone pair of electrons. For this one required 2. For this one it is 3. For this one also it is 3. Again for the carbon atom, formal charge on carbon atom. The number of valence electrons are 4. Because for the carbon atom, the electronic configuration is 1s2, 2s2, 2p2. Valence electrons are 4. Minus the number of lone pairs. On the carbon atom, there is no any lone pair. That's why it is 0. Minus the number of bond pairs are 8. Bonds are 4. That's why bond electrons are 8. So the formal charge on the carbon atom is 0. 4 minus 4 is equal to 0. Now let me write this as oxygen 1, this as oxygen 2, this as oxygen 3. For the oxygen 1, 6 minus the number of lone pairs 4 minus the number of bond pairs 4, half into 4, that is equal to 6 minus 4 minus 2, that is equal to 0. So for this oxygen atom, the charge is 0. For the oxygen atom 2, again 6 minus the number of lone pairs 6 minus half into the number of bond pairs 8. Number of bond pairs 8. 6 electrons. So it is nothing but equal to 6 minus 4. It is minus 2. Should be minus 1. Half of. Actually here it is 2. Because between this oxygen and carbon there is only 1. That's why it is 6 minus 1, that is nothing but equal to minus 1. For the oxygen 3 also we have the same 6 minus 1, that is equal to minus 1. That's why we can rewrite the structural formula as C double bond O, O minus, O minus. But these structures can undergo resonance. That is, negative charge may come here, or double bond may go to this place, or double bond may go to this place, and negative charge may come to this place. So this is about the formal charge on an atom. Though there may be no charge on the atom, we have to assign this because of some purpose. We need the directional properties of the covalent molecules. So to assign from which side to which side there is a direction of the bond or direction of the dipole moment, etc. So that's why we are writing this formal charge on the atoms. So take some more examples and calculate the formal charge on each atom. Okay, I will give you some examples. Write the formal charges on the oxygen as well as the sulfur atoms in the SO4 minus 2 molecules. Ion. So the Lewis structure we can write as S double bond O, S double bond O, O, O. Similarly, you write this formal charge on the oxygen atom as well as nitrogen atom with NO3 minus 1 formula. So write the Lewis structure first and then assign the formal charge for the nitrogen atom as well as the oxygen atoms. So in the next video, we will see the polar and non-polar molecules, polar and non-polar compounds, and the dipole moment for the polar molecules or non-polar molecules. So let us consider the polar and non-polar and dipole moment in the next video. Thank you.